Hi, my name is Scott Milne from National Energy Technologies. Today I'm going to demonstrate the effectiveness of our superior refrigerant lubricant supplement as compared to the standard Sunasol 3 refrigerant oil that most HVAC and refrigeration compressor manufacturers use when they create your equipment. Manufacturers make a one-time installation of this product into the closed loop system along with the ammonia or HFC-based refrigerant. System oil is critically important. It will vaporize and travel with the refrigerant, lubricating and preserving seals, bearings, and vital parts. This piece of equipment is an ASTM Falex lubricity testing machine. As evidenced in the laboratory with this device, our patented supplement oil has a 1,500 times higher lubricity than the standard. The higher quality oil is specifically blended to match your system and can extend equipment life, reduce running amps, noise, vibration, maintenance, and oil fouling. Oil fouling, as it's mentioned by ASHRAE in their 1985 handbook, will impede heat exchange and reduce system efficiency. 7% in the first year, 5% in the second, and 2% each year thereafter. And I quote, The vapor entering the condenser often contains a small percentage of impurities, such as oil. This oil forms a film on the condensing surfaces, creating additional resistance to heat transfer. Our oil is formulated to bond on a molecular level to the metal alloys that refrigerant lines are made up of, replacing the insulating oil and restoring peak efficiency. The molecule will coat, but not insulate. And it is so slick that the cheaper oil just can't stick. In the end, the result is more cold air, reduced delta T. So without further delay, let's begin our experiment. This demonstrator is made of a 1/2 horsepower motor in a device that is designed to put this motor under torque and then stop it so the amp load and the seize point can be identified. We will test these dynamics on a new bearing. This compares our supplement to the manufacturer's standard. First, as a control, we'll run the test without any oil in the reservoir. Please expect some noise. You'll see an amp increase. And let's observe the motor stopping pressure. Here we go. First we'll run dry. You would never do this, run your system without oil, but it serves as a nice baseline. Looks like it's ready to seize at about 25 pounds of pressure dry. Right before it seizes out, you're going to notice a steep increase in amps as well. I think we could say that's 25 pounds of pressure. Now we'll spin this bearing 25 degrees. It's hot. And we'll put our sump in place and add a little bit of Sunasol. We only need enough to coat the wheel. Okay, that's got it. Now let's test it with lubricant. It should perform much better. Not seeing much improvement. That's still about 25, 26 pounds of pressure. Notice the amps increase. You can say we're getting to about 26 pounds of pressure. There we go, a little better that time, 28 pounds of pressure. Now we'll go ahead and add some of our supplement. This goes in at about a 1/10 additive, so we won't need much. A few drops. We'll turn the bearing and try it again. Notice the amps. They will rise, but not like before. I've got a wrench maxed out and the engine just won't stop. Now we're going to test its ability to molecularly bond to metal. I made that claim and we can check that right now. What we'll do is we'll lower this sump back down and dry off the wheel. Dry off the bearing and see how we perform dry this time. 75 pounds of pressure, dry. The motor won't even stop. There we go. It seizes out about 65 pounds of pressure. That's 3 times the other oil. Let's try it again. Not bad. 65, 70 pounds of pressure. That's pretty good, dry. Now let's take a look at these bearings. You would think under that last test that we would have really punished this bearing. There is a small divot in it, if you can focus in on that. It's kind of polished off. It's small. But look at where we were when we were running our supplement oil. I don't even know if you can see that. There's barely a divot. It's actually polished off. And remember, we ran it on that for a long time. Now let's take a look at the Sunasol divot. That bearing is pretty chewed up. It's not polished at all. And it compares to the dry divot almost identically. So as you can see, our product does increase lubricity. It bonds to the metal. It reduces amps. And it will protect and extend equipment life. This product is already being used by Fortune 500 companies with great success. And the ROI on this one-time injection is generally between 6 and 12 months in a large application. Please contact National Energy Technologies for further detail, case studies, testimonial, pricing proposals, illustrating your ROI timeframes. Our company specializes in multiple advanced, fast ROI conservation technologies. We guarantee your satisfaction and are waiting for your call. Learn more at nationalenergytech.com.